So in this session, we will discuss all the different laws governing the electrolysis, which are called the Faraday's laws of electrolysis. So the first law given by Faraday was that the total mass of a substance which is deposited on an electrode is directly proportional to the amount of charge passing through the electrolyte. So the first law states that M is directly proportional to Q, where M represents the mass of the substance which is deposited at the electrode and Q would represent the charge which is flowing through the electrolyte. So M is directly proportional to Q. So we can write this as M is equal to ZQ, where Z represents the electrochemical equivalent, which is represented by ECE. So ECE stands for electrochemical equivalent and it is given by the alphabet Z. So Z can be written as M by Q. So Z basically means how much is the mass deposited on an electrode per unit charge which is flowing in the electrolyte. So the SI unit of Z, or the electrochemical equivalent, SI unit would be kilograms per coulomb. So this is the first law of Faraday. Now let's say if current I is flowing for a time t. So if current I is flowing for a time t, this implies the charge passing is the product of current into time. So if I substitute the expression of charge in this equation, so we will get M as ZIT. So this is the complete first law of Faraday, which connects the mass of the substance deposited on an electrode with the total charge which is flowing through the electrolyte. Now let us consider two different cases when the amount of charges flowing through the electrode is the same. So Q1 is equal to Q2. Now we see that in the expression that mass M is directly proportional to Z. So if charges are the same, so we can write that M1 divided by M2, that is equal to Z1 divided by Z2. So after this we will be discussing the second law of Faraday. So now we come to the second law of Faraday. Now this law states that the mass of the substance which is liberated at an electrode by passing a given amount of charge, that is directly proportional to the chemical equivalent of the substance, which means M is directly proportional to E, where E represents the chemical equivalent. Chemical equivalent of the substance, and M would represent the mass of the substance that is liberated by passing a given amount of charge. Now let us consider two different cases when the amount of charges flowing are the same. So in that particular case we can write M1 by M2, that is equal to E1 by E2, where E1 by E2 would represent the ratio of the chemical equivalents in the two cases. Now if we recall, in the first law we had found out similar kind of relationship, and that was M1 by M2 was equal to Z1 by Z2, where Z represents the electrochemical equivalent. So now if we equate these two equations, so we can say that the ratio E1 by E2, that would be equal to Z1 by Z2, and experimentally it has been found that these ratios are constant. So we can say that ratio E by Z is always a constant, where E represents the chemical equivalent and Z would represent the electrochemical equivalent of the substance, and this value is called F, and this F is the Faraday's constant. Now this is a universal constant and it has the value of a charge. So 1 Faraday means 96,500 coulombs. So basically 1 Faraday is the amount of charge that liberates 1 gram equivalent of the substance. Or if we say that if let's say 96,500 coulombs of charge is being passed through the cell, so then 1 gram equivalent of the substance will be liberated. So this was a brief discussion on the Faraday's laws.